So simultaneous, the actual word simultaneous means to happen at the same time. So what it's saying is that these equations are all happening at the same time. They're all interconnected. And you have two or more equations that are occurring at the same time. Now, you might recognize this because we actually did, this is one of our, like the Motivate email check-ins. So you've actually had some practice, maybe not realizing, but you've had some practice with simultaneous equations already. So we're not going to solve these. Oh. Hold on. We're not going to solve these just yet. I just want to show you how we can sort of write these out. So let's say if I was replacing apples with, say, an A, on this side I could have A plus A plus A, but I'd probably rather just write 3A. My first equation would be 3A is equal to 120. Second equation here, you've only got one apple, but in total, we've got 4 bananas. Let's say 4b equals 100. And finally, 3 bananas plus, I think it's a grape, 1 grape plus 1 apple equals 105. So these are just some examples of simultaneous equations. And if you're one of the people who did work it out, I think it would have been last term when we did this one, you actually solved some simultaneous equations. However, often they're a little bit more complex than these. We're going to have a look at some examples here. There's 2 strategies that you can use to solve simultaneous equations. You can either use substitution or you can use elimination. We're going to have a look at both. But in my personal opinion, I think substitution is a lot easier. I think it works a lot more often, whereas elimination, it's only really helpful sometimes, but we'll learn both of them. So let's say we had these 2 simultaneous equations. Something you'll note is that if you have 2 variables, so we've got x and y here, you have to have at least 2 equations to solve it. In this example up here, because we had 3, we've got A, B, and G, you have to have 3 equations. So the number of variables you have to have the same number of equations. But I'm fairly sure in this course, we do only look at 2 variables. So we'll only ever have 2 equations. So don't stress about that. Whenever working out simultaneous equations, you need to get in the habit of labeling or listing your equations. So I've chosen this to be equation number 1, and this one we've chosen as equation number 2. So always get in the habit of labeling them. Now, this has been taken from the textbook. We're just going to run through and explain how they're solving this using substitution. So you can see this is labeling, these are the same equations that I had before. This is equation 1 and this is equation 2. The first thing you need to do is express one of the unknowns, so one of the variables, from either equation in terms of the other variable. So if we're looking at equation 2, see we have x on our own here. So the text has decided it's going to make x the subject of this equation. You can see here, all they've done is they've sort of brought the 2y onto the other side of the equal sign. So if you're making x the subject here, you've got x is equal to -3 minus 2y. Now that you've done that, what you can actually do is you'll notice in this equation here, you've got an x there. And because they're the same x, you can substitute this into that equation. So you can see here, instead of writing 2 times x, we've just written that whole thing out. So we've just sort of said x is equal to -3 minus 2y, and we've just plugged it in there. Once you've got that, you'll notice that across this whole thing, there's only one unknown. So if you just sort of give it a quick scan, all you've got is y. That's the only variable. So we can simplify it. And I've sort of written the steps out here on the side because I don't think these are detailed enough. Let's say if we start with this one up here, first you want to expand the brackets. So if you say 2 multiplied by -3, that gives you -6. Then 2 times -2y, you get -4y. And then we've got our -y equals 4 on the end there. Now we're going to gather the like terms. So these are like terms, -4y minus y. So when you gather those like terms, we end up with -5y. Then we can bring the 6 over to the other side. So we end up with -5y is equal to 4 plus 6. 4 plus 6 is obviously 10. And then we can divide both sides by -5. So we end up with y is equal to 10 divided by -5. So y is -2. Right. So you can see why last week we focused a little bit on rearranging equations. Because when you get to something like this, if you need to solve for y, it becomes really handy knowing how to rearrange those equations. Once you've figured out one of them, we can just substitute y equals -2 back into this bit here. So you can see here I've got, I haven't really written that out properly, have I? They've done it here actually, we'll ignore that. Yeah, they've just put -2 into y there. And we end up with x is equal to -1. So we've solved for y and we've solved for x. Now, something I want to point out, it's not actually part of the course, but I think if you give it a bit of thought, it might help you understand what's going on a little bit here. So when we used the substitution method, we had y was equal to -2 and x was equal to 1. And what that actually is, it's where those two lines actually intersect each other. So these two equations, if you rearrange them to make y the subject, this equation 1 would be y equals 2x minus 4. If we rearrange this to make y the subject, and if we did the same thing here, we would have y equals -1/2x minus 3/2. And you'll notice that that's in the form of a linear equation. You might have done linear equations before, like on a graph. But if you actually plotted both of these like they've done here, you'll see that straight lines, they always have one point of intersection. And that intersection coordinate is what we solved. That's essentially what you're doing. You're finding the point where whatever you make x and y, it's when those two equations equal each other. Now, if you're a bit of a visual learner, that might help you understand what's going on. But if I've confused you a little bit more, don't stress, because it's not, knowing this isn't really part of the course, but it might help you understand it a bit better. So what I want you to try to do is have a go at these simultaneous equations using the substitution method. So just to quickly recap, when we use the substitution method, we chose one of the equations to make, in this case, we made x the subject, so we had x on its own, and then we were able to substitute that into the other equation. So we've substituted that whole thing. Then we solve for y, and then substitute y back in. So there's a few steps there. So have a crack at doing these two. Let's have a look at these ones using the substitution method. So the first thing I'm going to do is label these equations. So let's say this is equation 1 and this is equation 2. So now that I've labeled them, I know it's going to help me sort of organize myself and what's going on. Now, because I'm going to use the substitution method, I want to rearrange one of these equations to have one of the variables as the subject. Now, because this x here doesn't have a coefficient, it's going to be the easiest one to do, because you can imagine that if we were rearranging for this y, at some point we would need to divide by y, and we get some really nasty fractions in there, and it would be a little bit frustrating. I think the best way to do it is to rearrange this equation to make x the subject. Now what I can do there is, if you subtract 5y from each side, we're going to end up with x is equal to 10 minus 5y. So that is the first part of the equation. Now we need to substitute 10 minus 5y into the first equation. So because we know x is equal to this, we're just plugging it straight in there. And when we do that, this equation will become 7. Instead of writing x, I'm writing 10 minus 5y. Then we've got minus 3y equals negative 6 on the end. So this is the equation that we need to solve. We're going to solve for y now. That's what we're going to do. So expanding the brackets, we have 7 times 10 is 70. Then 7 times minus 5y is minus 35y. Now that we've expanded the brackets, I'll just add the rest of the terms on. Okay. Now we have some like terms in here. We can join these together because they're like terms. So minus 35y minus 3y, simplifying that, we get 70 minus 38y equals negative 6. Now I want to subtract 70 from both sides so I can get rid of this 70. We have minus 38y is equal to negative 6 minus 70. Now negative 6 minus 70 should be negative 76 if my maths is correct. And we can divide both sides by negative 38, and that will get us the y on its own. I've got y is equal to negative 76 divided by negative 38. And I think if I plug that in my calculator, I should get y is equal to 2. So I've got y is equal to 2. Now that I've got that, I'm just going to get rid of some of this working here. How is it negative 70? So what I've done is this, after this step here, I've subtracted 70 from both sides of the equation. So you can imagine if I do a minus 70 there and a minus 70 on that side, this positive 70 and this minus 70 sort of cancel out. I'm subtracting 70 from either side of the equation. Now that I've got y is equal to, the imaginary plus, it can be tricky. So now that we've got y is equal to 2, I'm just going to get rid of this now. I can plug that into this equation, and I'm going to get x. So if I know y is 2, instead of y, I'm just going to write 2. 5 times 2 is 10, so 10 minus 10, and x is 0. So we've got y is 2 and x is 0. That's our answer to the simultaneous equations. So if you were to plug in 0 and 2 there, you'll get negative 6. And if you were to type in 0 and 2 there, you would get 10. Now this next one, we're going to use substitution again. So again, I'll label my equations. Equation 1, equation 2. Because x has a coefficient of 1 in both cases, we could really use either equation. So just because I'm choosing to, I'm going to do this one. I'm going to rearrange it to do x is equal to 12 minus 2y. Whether you use equation 1 or 2, it actually won't matter. As long as you do the maths correctly, you'll end up with the exact same answer. So we've got x is equal to 12 minus 2y here. So now I'm going to plug that into here. So instead of writing x, I'm just going to write 12 minus 2y. 12 minus 2y minus 3y is equal to 2. All right, now this is the equation we need to solve. Because these are like terms, we can join them together. So negative 2y minus 3y, we end up with minus 5y here. Now, if I subtract 12 from both sides of the equation, we get negative 5y is equal to 2 minus 12, which should be 10. So we have negative 5y equals 10. Get rid of that. And then I can divide both sides by negative 5. So y is equal to negative 2. That'll be 10 divided by negative 5, which gives you negative 2. Now that we've got our answer for y, as we did before, we can substitute it into this equation, find out x. So instead of y here, I'm going to write negative 2, and I'm just going to solve it. So x is equal to 12. Now this bit's tricky, actually. This is actually negative 2 times negative 2. So this actually simplifies to plus 4. That's a tricky one. So you have to consider this as actually a negative sign as well. That's negative 2 times negative 2. So we end up with 12 plus 4, 16. So y is 2 and x is 16. And that's our answer.